let's take a look at how we can use Swift and SwiftUI to prototype custom UI components. We're going to build a completely custom UI to be able to visualize the sound level, both showing the instantaneous sound level as well as sound level over time. So let's jump straight into how we can build such a component and how Swift and SwiftUI can help us prototype it along the way. To show the instantaneous sound level, we're going to build a gauge that looks similar to what a speedometer in a car looks like. We start out with a plain circle, and as a first change, we'll try to add a border to it. We can do that with a stroke that follows the outline of the circle. You can see here that we have hard-coded the line width. But to make code a bit more tweakable and readable, we're going to move it into a separate property. This removes friction, because when we want to find values and we want to tweak them, it's nice that they're all grouped in the same place in the top of our code. We also get the opportunity to explain our constants a bit. So here we call it the thickness of the gauge. Finally, it helps us be able to reuse this thickness value if or when it's needed for other parts of the view down the road. So the next thing we want in our prototype is to create a natural start and end point. A speedometer typically does this by leaving a gap in the circle. So that's what we've done here by trimming the circle before we apply the stroke. Again, we are keeping our constants in properties in the top of our view. A final step we can do to make our gauge a bit more usable is to use vars instead of lets. This enables Swift to synthesize our initializers automatically. The initializers even support our default values. And this flexibility enables us to tweak things locally, but without giving up on the customizability from the outside. In general, I like to expose many properties on small views like this to avoid locking ourselves in too early. It leaves us open and flexible to tweak things in a later stage. What our UI needs now is some colors. So let's add all of them, or at least most of them. Here we add a gradient that is masked out by our gauge. And when we look at the code here, it feels a bit wrong to me, and let me explain why. The gradient wraps our gauge, and what we do mentally is that we're applying some styling to our gauge. So I think we should reverse this order and nesting here. Let's imagine that we want to have this kind of dot syntax instead. This isn't normal SwiftUI API. But we can implement it with a small extension on the view type. And as you can see here, it's fairly straightforward to use a Swift language feature like extensions to improve the usability of SwiftUI. The new dot syntax here also allows us to quickly comment the styling call for adding our gradient in and out as we please. When we remove developer friction like we do here, we enable ourselves to iterate more quickly and avoid blocking our creative process. It's often also quite convenient to be able to toggle styling on and off programmatically. Let's say that this gradient depends on other tweaks in the prototype, and we want to be able to control whether or not it's colorized, just like you can see in the code here. To be able to conditionally apply calls to view types in this convenient way, we're going to extend SwiftUI again. We make an extension on the view type that takes a Boolean value as well as a transformation closure. Depending on our condition, we decide to transform the view itself or not. Note that everything here is wrapped in a group, which is needed since the types of the two returns that we have might be different. The two return types are the transform itself and self itself. This also means that flipping the transformation on and off can't be animated nicely, since SwiftUI's diffing algorithm for animation is based on the types themselves. In our case, we don't mind about this trade-off, since we're not going to use this for user-facing changes, only for tweaks in our prototyping process. For some parts of the tweaking process, it can be useful to be able to tweak the prototype without having to change code. but instead to be able to tweak it interactively. For instance, when we want to get feedback from our colleagues, or when we have a lot of parameters we want to iterate through simultaneously. So let's say that we want to tweak the thickness of our gauge in this way. In this case, a slider is fitting, but in other cases, toggles and text fields can also be quite convenient. In general, we want to go for standard input control, since we don't want to have spent too much time setting it up. In the code here, we make a state property for the thickness of our gauge and set up a slider to modify it. We add a slider right next to our prototype in our UI with a matching label and the current value, and we make it bleu. Let me just move my cursor over to the other screen here and see if I can find it and see if we can tweak. As you can see here, we can now tweak the thickness of our gauge very intuitively. I tend to add sliders for many parameters at a time to be able to adjust them simultaneously. So here we add another one that is orange. It's for dashing of the borders, so we can tweak the look of the gauge a bit. See if I can find the mouse again. We can go for a very thick look. And let me just add a little bit of dashing, just some narrow gaps here. This is one look we could go for. But we can also go in the other direction. So let's say we want to have this one all the way down here. So this is a nice slider, so we can just click where we want it to go. So let's just bring it all the way down. And let's say that we want to have the gap a little bit more like this, with a bit more even spacing, a bit more contrast. I think we'll keep the last look here. We can really see how fast we can change the overall look, and with very little friction. So it's really useful to have these interactive controls instead of having to change everything in code all the time. A real speedometer has labels to show what different positions represent. To be able to position them, we're going to take a look at layout. When we want to lay out things for a prototype, we could prioritize quick over perfect, but sometimes we want to try to build something highly customized that can't be done quickly. So we need to find a balance. The stack views and the frame modifiers are our go-to thing for most things when dealing with the layout. So here we start with a C stack. We add all the labels that we want to position around the gauge to our stack. And since they're laid out along the C-axis, their sizes and positions don't affect each other. This gives us the needed freedom to do custom layout for these labels. The next step is to use the frame modifier, which works a bit different than we might expect. So to better understand how the frame call works, I'm filling the background of our labels with a color here. Now we add our frame call where we specify that we want to have the label stretched infinitely in the vertical direction. And as we can see, it stretches to the height of its outer view. I've also added a border after the frame call, so we can see how the size of the label itself didn't really change here. By default, the frame call aligns its content in the center, but here we specify that we want the label to be aligned towards the top of the frame. And as a last step, we can now rotate the framed labels using the built-in rotation effect call in SwiftUI. To see our final result, we remove the helper colors. It's quite powerful how little math calculations we had to do here, even though our labels are laid out in a fairly customized way. That doing custom layout is this accessible in SwiftUI really helps building custom UI components. Let's say that we want to fill the trimmed gap in our gauge with some brand text. We could do this in a similar way that we just did before, by taking each character in our string and putting them in separate labels. But the kerning is a little bit off here. So in this case, we want more control, so that we can do a more precise calculation of the angles that we need for each string character. So let's see how we can use another SwiftUI feature to give us the sizes of each of the character label so that we can fix our kerning issue. The first step is to use the background modifier. That stretches the entire size of the text label. Secondly, we use a geometry reader to get the size of our background view. To be able to store this size to be used outside the scope of this geometry reader, we can use something called the preference key. First, we have to implement a preference key. And here we implement one that can aggregate the sizes of each label for us. The preference key works by setting a preference on a view, but we don't even have a view inside the geometry reader. So as you can see here, we've added a transparent one. And then we store our sizes into it. It's a bit tricky. But now we can listen for our preference key on any outer view and use them as we want. So that's what we do here. So we can lay out our text labels more precisely, where we use the sizes of the individual character labels to calculate more precise angles. When we remove our debug borders, we see that we now have much nicer spacing between the characters. So from time to time, you might run into a wall when trying to do custom layout in SwiftUI. And this technique using the preference key can be a good way to climb those walls. So our prototype is coming along nicely, but so far it's very static. We're building a prototype that is going to be driven by sensor data, so we should make sure to prototype that aspect of it too. We'll use some random data to mock the sound level. And creating the random values themselves in Swift really couldn't be any easier. To be able to drive our prototype with our random values, we create an observable object. We set up a timer to provide a new random value at a suitable time interval. And we publish them through a property. In the place where we use our gauge, we create an observed object property with our audio object. And now we can use the decibel level from it to drive the trim of our gauge. No more steps are needed, since SwiftUI now takes care of re-rendering our prototype with every new random value. So being able to mock our data this way is very powerful. But we can also feed live sensor data straight into our prototype using the exact same technique. It just requires a little bit more work, depending on what type of sensor data we want to use. For getting access to the microphone on the MacBook here, it only takes the work that you see here, besides some settings for privacy entitlements. It's not that much code, but of course, the sensor frameworks might not be familiar to us, so we need to consider if it will be worth it for a prototype. So the payoff is that now you can see that it's reacting to what I'm saying. Much more realistic. So let's say that we are done with our gauge and we want to visualize the history of our sound level next. We're going to make a circular graph that is suitable for this radar-style grid. To make a circular graph, we need to do custom drawing. And we can use the shape type for that. Then the only job for us is to create a path given a certain rectangle. Based on that rectangle, we can now set up and calculate our path. You can see that we find the center and we find the radius, and we use that to calculate the points on our circular graph. We'll style the graph with a gradient so that the values of our graph matches those of our gauge. As you might have noticed, we use our handy little call extension from the very beginning of this talk to be able to apply our gradient here too. Animation literally means bringing things to life. So let's try to finalize our radar graph with a little bit of that. The first thing we do is we add a line on top of our graph to indicate the most recent sound level. And secondly, we fade out the graph a bit as we go back into history to put emphasis on the most recent sound levels captured. And since both of these are rotated using modifiers that are within the same view scope, we can animate both of them with a single animation call. We'll animate linearly, and we use a duration that matches how often we receive new sound levels. giving it this continuous scanning look. The movements in the gauge is now starting to look a bit choppy right next to our smooth graph. So let's add a simple animation to the graph too. So if we move it up here, we can see we can take it all the way up. And it's kind of going slow in a similar way to the sound level history. But we kind of still want to keep a little bit of the instantaneousness of it. So let me just bring it down to a suitable level like this. So once you start tweaking your animations in this way, you'll soon realize how perfect SwiftUI is for prototyping animation-heavy design, not even just for UI. Okay, so we're coming to an end. Our prototype is ready for some final testing. So I want the help of every single one of you. So now please, make as much noise as you can and see if we can make it flash. Perfect. Thank you very much. Best testers in Paris in this theater. So now we've seen how Swift and SwiftUI can empower us when prototyping custom UI. And we've seen a few things we could do to make it fit our prototyping needs a bit better. For all the things we did here, we never had to leave Swift or SwiftUI. Not for the custom layout, not for the custom drawing, and last but not least, for the animations. Swift and SwiftUI is quite a powerful combination, in particular when it comes to prototyping. So a lot of folks have shared a lot of things about how to do things in SwiftUI. So a big thanks to all the people up here. You will recognize some of the names from today as well. Thank you.